Okay, so we are beginning now the part 2 of our Module 8 review quiz. This is a multiply and then simplify if possible. So what we're doing is this is a basic distributing problem. So when we look at this, we are going to distribute and multiply the square root of 10y times the square root of 10. Now, normally I would not write this part out, but what we have here is a 10, and a y. When I distribute here, we have a minus, we have the square root of a 10, a y, and a y. So remember, square root means that you need a pair of the same numbers. Since this first one has a pair of 10s, when I do the problem, I would initially go ahead and write the 10 not under a radical because we're going to take it out, and what's left is going to be the square root of y. Then we subtract. Here, when we distribute, we have a pair of y's, so it's the y that comes out, and what's left under the radical is that single 10. I personally don't write 100y and 10y squared. When I distribute, if I see I have a pair of the same, I like to recommend that you start taking that out then rather than writing it longer and then having to come back and do a lot of extra simplifying. Write with positive exponents, simplify if possible. So negative 49 raised to the negative 3 halves. So we have negative 49 in a parenthesis raised to the negative 3 halves. When you do this problem, please use your calculator. Okay? So here you're going to type in your negative 49. You're going to raise it to the power of a negative 3 halves. Okay, we're going to press enter. Now, notice we get an error message. It says non-real answers. So, for this particular problem, if I come back and I look, I have two solutions. I could type in an answer, or it says the answer is not a real number. So if you will type this one in on the calculator, you will see that when you get this error message, what you're going to give for your solution is not a real number. And that's going to be the answer that you choose on the computer. Okay? Here we have the cubed root of negative 7 raised to the third. We have the cubed root of a negative 7 raised to the third. I just want you to see exactly what this means. Negative 7 to the third means that negative 7 is under the radical 3 times. In order for something to come out from under the radical, since it's an index of 3, you need 3 of the same. So my answer for this is going to be a negative 7. Yes, you can have a negative answer if your index is odd. You can have a negative answer if your index is odd. Another way that you can do this, and you're going to go to your calculator. I'm going to do a 3 for my index, math. I'm going to choose number 5. Under the radical, I'm going to type in my negative 7, and I'm going to raise it to the power of 3. You may also type this in on the calculator, and then when you check, you get your negative 7. Use the quotient rule to simplify. Assume that all variables represent positive real numbers. Okay, so let me copy this down first. We have a z to the fourth over 27x to the ninth. There's a radical around everything. There's an index of 3. And that negative is just in front of the problem. It is not part of the index. Let me say that again. That negative in front is not part of the index. So when we're using the rule and we're just simplifying, let me oversimplify this and write it out the long way just so you can see. Z to the fourth means you have 4 z's. 27, if we factored it, would be 3 times 3 is 9, times 3 is 27. X to the ninth means you have 9 x's. So when I simplify this, since my index is 3, I need 3 z's for a z to come out. Okay, so in my answer, there's a negative sign in front. In the numerator, I'm going to have 1 z that comes out, but notice there's still a single z underneath. And I still have to keep the index of 3. So a group of 3 z's made 1 z come out. This one stays under. So that's what this looks like. In the denominator, I have a group of 3 threes. So that means I have a 3 that comes out. For my x's, I have 1, 2, 3 groups of x's. So that means I have 1, 2, 3 x's that comes out, which is x to the third. There are no x's or 3's left under the radical. So this, what you see here, is your final solution. Another way you could look at this would be 3 goes into 4 one time, 1 z comes out, and then when you subtract, there's going to be 1 z left. The cube root of 27 is 3, and 3 goes into 9 evenly 3 times. Use the product rule to multiply. Assume that all variables represent positive real numbers. So we have the fourth root of 7x cubed, the fourth root of 7x cubed times the fourth root of 5. Type an exact answer using radicals as needed. So as I do this problem, the index is a 4. 7 times 5 is 35. I can multiply them because they are both numerals under an index of 4. And then I have x to the third power. For this problem, aren't 7 and 5 both prime numbers? I don't have 4 of the same numeral underneath. I have x to the third. There's only 3 x's. I would have to have 4 for something to come out. So for this problem, I stop. I'm done. That is the answer, the fourth root of 35x to the third. Match the graph with its equation. So, and then we're going to write the domain and interval notation. So we have f of x is the cube root of x minus 3. So f of x is the cubed root of x minus 3. So we're going to use the calculator. We're going to go to y1 equals, and we're going to type the equation. Okay, so let's come here to our calculator. Let's go to y equals. So we have the cubed root of x minus 3. Once we type that in, we press graph. You want to be sure you're at the beginning value. So we want to be sure we have chosen zoom 6, which is the standard view. It could be your graph could be off somewhere. So let's make sure we're at our standard view. Notice it's in quadrant 3 here. It moves into quadrant 4, and then it crosses up at the 3 up into quadrant 1. So as I'm trying to choose my correct graph, this looks like it could be the correct graph. This one's not right. This one crosses on the negative side, and this one does not go up into the first quadrant. So through process of elimination, we can come here and choose easily what that happens to be. Then it asks me, what is the domain of the function? The domain, and let me just do a quick little sketch here. So it's like here, it crosses at 3 and up in here. The domain, remember, are your x values. So if I'm looking at my x values, and we always go from small to large, this goes off the page, and these x's go off the page. So my domain in interval notation is negative infinity to positive infinity. And with interval notation, we always use parentheses for infinities because there is no endpoint. Solve the following for x. X squared plus 14x plus 4. X squared plus 14x plus 4 equals 0. Now, at first, you might be thinking dma080, oh, let's factor using the calculator method. If we have 1 times 4, the only factors are either 1 and 4 or 2 times 2. Neither of those will give us a value of 14. So we can't use that most simplistic way. This is one of those before that we would have said it is prime because we couldn't find the middle number when we looked on the calculator. Instead, what we're going to do is identify our A, our B, and our C, and then we're going to use the quadratic formula, which is the opposite of B plus or minus the square root of B squared minus 4 times A times C, everything over 2A. This is going to be section 8. Section 8 is going to show you that any of those problems that we used to say were prime, we can still factor as long as we use this method. The one thing that's important with this method is that if your B is a negative, remember to put a parenthesis around it because the opposite of a negative would make it a positive. And when you type something in and square it, if the parentheses is not around the negative sign, you get a negative number, not a positive number. My A here is going to be a 1, my B is going to be a 14, and my C is going to be a 4. So as I do this, I'm going to have the opposite of 14 plus or minus the square root of 14 squared minus 4 times 1 times 4. Everything is over 2 times A, and A is a 1. So I would recopy my negative 14 plus minus, put the radical sign. 2 times 1 is a 2. This part here I like to do on the calculator. So let's go to our calculator. And we're going to do 14 squared minus 4 times 1 times 4. I just want you to multiply the numbers under the radical. Do not put the radical sign here on the calculator. We get the number 180. So underneath, we're going to do 180. Now, to simplify this, remember, we're going to go to y1. We're going to do 180 divided by x squared. Then we do second table, and we're looking to simplify it. We look for a 1 to see if it's a perfect root. So here, we're going to do 180 divided by x squared. Second table. As we look in this column, I would keep going down We want to go and see if there is a 1, but there's not. If there's not a 1, let your eye start coming up, and the first pair of whole numbers would be 6 and 5. The left comes out from under the radical, the 5 stays under the radical. So this would be 6 square root 5, and then everything is over 2. So the 180, the square root of 180 is a 6 square root 5. To simplify, we can only simplify if all 3 of the whole numbers have a common factor. The greatest common factor for all 3 of those is going to be a 2. 2 goes into 2 once, 2 goes into 6 3 times, 2 goes into negative 14, negative 7. So your final answer is going to be negative 7 plus or minus 3 square root 5. And that would be your final solution. When you type in this on the computer, there is a key. You'll find there is a key. I'm going to put key on. Now, it's not on the computer keyboard. It's on the computer. I'm going to call it the computer pop-up. When you're in the area to type in your answer, if you click on where it says more or it has those symbols, you will find that key so you don't have to retype that 2 times. Okay? Okay, we still got plenty of time, so let's keep on moving on these. Add or subtract. So we have 12 cube root 6, 12 with a cubed root of 6, minus 10 square root 6, plus 15 square root 6. Okay? So I'm going to make note here that we're going to combine like terms. Now, for these to be like terms, the index has to match. This is a cubed root, this is a square root, this is a square root. All of them do have a 6 underneath, but only these 2 can be combined. So I'm just going to bring down the 12 cube root 6. There is no like term with that. These 2 are like, so negative 10 plus 15 is going to give me a positive 5 square root 6. And we cannot simplify the cubed root nor the square root of 6, so that is your final answer. You'll find that a lot of these problems are actually very simple problems, but later, by the time you've gotten to more difficult things, you want to try to do too much stuff to a problem. So just step back and look at it in a simplistic viewpoint. This one asks us to find the midpoint of the line segment whose endpoints are these. Okay, so let's talk about the midpoint formula. We have 4, negative 9. And we have 7, 4. And we're asked to find the midpoint. Okay, so the midpoint formula, let me just label these. If this is from my first ordered pair and this is from my second ordered pair, the midpoint is going to be the middle point of the x's. So you're going to add the x's divided by 2. For the y value, you're going to add the 2 y's and then divide it by 2. And your answer is going to be an ordered pair. So it's really quite simple. My x's are 4 plus 7 over 2. My y's are negative 9 plus 4 over 2. X's, y's. 4 plus 7 gives me 11 halves. I cannot reduce 11 halves. Negative 9 plus 4 is negative 5 over 2. And I cannot reduce negative 5 over 2. So you're going to leave your answer It's an ordered pair, and you may leave those two values as fractions. Sometimes these values may simplify to a whole number. Rationalize the denominator. Assume that all variables represent positive real numbers. Now these are the fun ones, the rationalizing. 7 over square root 45x. 7 over square root 45x. And we are asked to rationalize the denominator. Now, when I explained this in a previous lecture, what I like for you to do is to simplify first if you can. So, that being said, that's just a 7. If I were to factor 45, and actually you can use your calculator to do this. I'm going to write it out, but then I'll show you the other way. We know that 9 times 5 is 45, right? So I could go to my calculator here, and I could do 45 divided by x squared. Second table, and a 1 should be in here. I'm going to scroll up for my first pair of whole numbers. My first pair of whole numbers is 3 and 5. So this is going to simplify to 3 square root 5x. Because remember, you need a pair of the same number for the 3 to come out. So that's why the 3 comes out, square root 5, and there's 1x. So when we rationalize, we want to remove the radical. If there's 1 5, it's a square root, the index is a 2. That means I need another 5 and I need another x. When I have a pair of 5s, the 5 comes out. When I have a pair of x's, the x comes out. Whatever you put on the bottom, you put the same thing here on the top. So my numerator is 7 square root 5x. In the denominator, the 5 came out, the x came out. 5 times 3 gives me 15x. If the 7 and the 15 could be reduced, I could reduce the whole numbers. But in this case, there is no more simplifying that I'm able to do. This one asks us to rationalize the numerator. Same process. The cube root of 2x to the 5th, the cube root of 2x to the 5th over 13. So, in this case, the 2 doesn't simplify, but I am going to write out all of those 5s just so you see what we have. 2 and 1, 2, 3, 4, 5 x's. And here's my 13. So, I have a group of 3 x's, so that means I have an x that can come out. But there's still 2 left. Those 2 are not enough to come out from the radical. So for me to simplify this, I have an x that comes out, and then I have the cubed root of 2, and I still have 2 x's, and the denominator is my 13. I've got to figure out what do I multiply by so that, and again, it's a cubed root, so I'm going to have to write these as cube root. If I have 1, 2, how many more 2's do I need to have a total of 3? I need 2 more. 1, 2, 3 2's means a 2 comes out. If I have 2 x's, I need 1 more x for it to come out. So let's think about what I just said here. I have 1, 2, 3 2's. That means my 2 comes out. I have 1, 2, 3 x's. That means my x comes out. So now in the numerator, my 2 came out. This x came out. I had already pulled out another x, so that's 2x squared. What we have here, I'm going to put in the denominator. 2 times 2 is 4x. x. None of that can simplify because there's only one or two of those items. So my denominator is 13 cube root 4x. And you're finished. That is your solution. There are numerous rationalizing problems on the test, so you do have to be sure you're comfortable with rationalizing the numerator and denominator. Same process, it's just either the top or the bottom. Use the properties of exponents to simplify this expression. Write with positive exponents. So we have 4u squared to the 1/2. We have 4u squared raised to the power of 1/2. That means the 4 is to the power of 1/2, and we have u squared raised to the 1/2. So 4 to the 1/2. You can use your calculator. 4 raised to the 1/2. And that's going to give us a 2. U squared to the 1/2 means we're going to multiply 2 times 1/2. So 2 times 1/2 is going to give us 1. And we don't need to write the understood 1. And you're done. That one's finished. That was section. Actually, the property rule here is what we learned in DMA 60 in that very first section. You never get away from DMA 60, do you? Solve given an exact answer and a 2 decimal place approximation where appropriate. A wire is needed to support a vertical pole that is 16 feet high. The cable will be anchored to a stake 9 feet from the base of the pole. How much cable is needed? They want an exact answer using radicals, and then they want a decimal answer rounded 2 decimal places. So we have 16 and we have a 9. Okay, so let me write this down. We have a flagpole. This is 16. This is 9. There's our flag. And we're looking for the length of the string. Okay? So when you see this, you should recognize, oh, Pythagorean theorem, right? So we're going to have a squared plus b squared equals c squared. So that's going to be 16 squared plus 9 squared equals x squared. Okay, let's go to our calculator. We're going to have 16 squared plus 9 squared. That's going to give us 337. So 337 is equal to x squared. But we need the answer for x. So that means we're going to take the square root of both sides. So the x comes out and we have the square root of 337. We're going to see if it simplifies. So we're going to do that first for the exact answer. For the exact answer, let's go to our calculator. At y equals, clear, you're going to do 337 divided by x to the second power, second table. We're going to look in the right column, and I got to go way down and get to if there is a 1. Okay, a 1 should be in here. It's not a perfect square root. So let's come back up. We're looking for the first pair of whole numbers. And the first pair of whole numbers that we have, okay, this is the first pair of whole numbers, so it does not reduce any further. So my exact answer is the square root of 337. See if it simplifies, and I'm going to put it does not. So that's your exact. Then when they asked for the decimal approximation, they said to round 2 places. So let's come back to the calculator here. We're going to do second square root, and we're going to type in 337, and we get 18.3575. 18.3575. Since it asks you to give a decimal approximation 2 places, I recommend at least write several digits out. We're going to round it 2 places. We look at the third place to see how the number rounds. The 7 would make the 5 go up, so it's going to be 18.36. And this puts us about another third of the way. We're here at about question 24, so we'll start here for the next lecture. And let me